If you have students that are looking in here saying, I'm not sure what to do, I'm crossing things out, I'm not sure what the things I'm crossing out, bring out those base 10 blocks and let them play a little bit. Let them understand what's happening. Today we're going to talk about some base 10 blocks and talking about these tools we can use for students at many different grade levels, from elementary school to middle school, even up to high school, building that understanding of how do we add, how do we subtract. And I am also going to show you a common mistake teachers make when they begin trying to use these base 10 blocks, especially with subtraction. We're going to show a mistake that a lot of teachers make and a way to avoid that mistake. But before we get to that, let's talk about what these base 10 blocks are, because maybe you're familiar, maybe not. In this particular case, we've got some kind of square grids, kind of like rods, sometimes we call them. They're kind of connected here, and then some little singles here. So in this particular case, we're going to call these hundreds because it's a 10 by 10 grid. That counts as like 100 pieces, 100 of an element. And these are tens, because of course there's 10, and these are ones. Now these could also be ones, tenths, and hundreds. They could be a lot of different ways. But for today, we're going to talk about them as hundreds, tens, and ones. We want to make sure that we do build that flexibility, that understanding that this doesn't always have to equal 100, but for today it will. So if this is 100 and this is 10 and this is 1, we can look at this particular set of base 10 blocks and say, really what we have here is we have 236. 236 as I look at that. And again, if I process, what does that mean? Where are those coming from? Again, I'm looking here, I've got 200, so 200s, and I've got 30, 3 tens, and then I've got 6 ones, so that's 6. So really I can add all these together. 200 plus 30 plus 6, looking at this. So that's that 236 where that's coming from. So the nice part about base 10 blocks is I can take base 10 blocks and I can do a lot of things with them. And we can talk about simple adding. I'll come back out of this for a minute. We'll come back to that in a bit. I can come into here and I can say when I'm adding base 10 blocks, here I've got 236. If somebody said they wanted to add 40, here's 40 more I want to add. All I need to simply do is kind of add them in there and see how many I have. I'm going to shoot these guys over here a little bit, see what we're doing here. So now I've got, let's see, I added 40, so those are the 40 I added. So now I've got 200, 10, 20, 30, 40, 50, 60, 70, 1, 2, 3, 4, 5, 6, 276. By adding 40, I simply added 4 of these lengths here that are all 10. Super easy to do, 246. I'm going to go back to my 236. I'm going to bring it back over to here and say, what does that look like in my scenario here? In that particular case, we added 40. So instead of 236, what we ended up having is well, there's the hundreds didn't change. There were still the same hundreds here, so we're looking at this. So I've still got 200, but this time instead of 30, now I've got 7 tens, or 270, and my 6 didn't change. I got 276 when I'm adding 40 like that. And that's a way that I can process how to add base 10 blocks and such too. Let's say I had a subtraction problem, and I wanted to think about 236. So here's 236. Minus 124. Let's think about that. 236 minus 124. Now the nice part about using base 10 blocks is I can quite literally see 236. And when I'm saying minus, I can think about take away or remove. So in this particular case, I can say, okay, we're going to take away 124. Well, this is 100, so I'm going to remove 100. I'm going to remove 20. And I'm going to take away, subtract 4. So when I do that, here's the pieces I removed. I'm taking them away. I'm going to set them off to the side. And when I remove that, what I end up with is let's see, 100, 110. So looking at that, so a 10 and 2 looking at that. So that's a great way that I can use subtraction with base 10 blocks. Another way I could think about that is I'm going to come back to my 236. I come back to my 236 and I can, same exact thing. I'm just going to kind of rewrite it here, 236. Take away 124. Last time, I'm not sure if you recognized, I removed the hundreds first, then the tens, then the ones. Just want to show us we can do it the other way too. So I'm looking at this 236 minus 124. What if I wanted to remove the 4s first? So I remove the 4s. I'm sorry, remove the 1s, I apologize. Taking the 1s, taking 4 1s away. Now I'm going to take away 2 10s. That's my 20. And I'm going to take away 100. So I'm still left with that same amount. I still took away the same amount. Oops, dropped one over there. I'm still taking away that same amount, and I'm looking at this, and the amount that I have left is 112. And as I said a little bit earlier, there is a common mistake that a lot of teachers use when they're teaching this idea with base 10 blocks, whether it's with hundreds or tenths or wholes. There's a common mistake we do see with subtraction. I'm going to show you a little bit later, but I do want to show you a way that we can really use base 10 blocks to understand what does it mean to borrow, and think of some of these pieces. A lot of us when we were younger learned about crossing things out and borrowing for the next one over. And I want to kind of challenge you to maybe not use that word so much anymore, because sometimes when we say borrowing, it doesn't really have a whole lot of mathematical meaning and students don't really understand it. So let's go back to our 236. We're going to go back over there. I'm going to set my 236 up. So here's 200. Oh, that's 100. Here's 236. So we're going to kind of look at this and see, here's my 236. And last time I subtracted 124. But what if I wanted to subtract something a little bit different? What if I wanted to take 236 and I wanted to subtract 129. Now, some of you knew I was going to get there. Some of you knew I was going to this place. But if you didn't, that's totally fine. So here's 236 minus 129. So I'm going to go back to the idea of last time it was 236 minus 124. And I was able to remove these 4. I was able to take these 4 out. The challenging part here, though, is if I want to literally take away, literally remove from these base 10 blocks, because this does represent 236, I don't have 9 to remove. I can remove 4, 5, 6. I can remove 6, but I don't have 9 to remove. So what I can do, though, is I can think about this. Now, this is a solid piece. I'm not sure if you've ever touched one of these before. It's a solid piece. I guess I could cut it up. But we actually make these so I can kind of exchange these. But I'm going to exchange these. I'm going to rename this 110, this whole 10. I'm going to rename it as 10 ones. So I'm going to kind of put that over here. So here's 5, and then I'm going to do 5 more. So I'm just going to confirm that I took away this 110 here. I removed the 10, but I exchanged it with, I renamed it with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I still have the 6 ones that I had there before. So I still have 200. Now I've got 10, 20, really 36 looking at this, but I renamed or decomposed, sometimes we use that term in math, I decomposed the 10 to be 10 ones. Now the reason I did that is now I actually have the ability to actually remove those 9. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I took those away, I'm removing those 9. So I removed the 9. Now I want to remove 2 10s, because there's 2 10s right there. So I remove the 9, so I'm going to remove 2 10s. I remove 2 10s. And then I'm going to remove, there's 100, I'm going to remove 100 here. So the amount that I have left when I look at this, 236 minus 129, I didn't borrow and cross things out. I didn't do that. I'm literally looking at if I had 236 of something and I removed 129 of them, because that's literally what I did, I'm left with 100, no 10s, 1, 2, 3, 4, 5, 6, 7. So 107 is what I still have left here thinking about this. So 236 minus 129 is 107. So now what I want to do is I want to think about, a lot of us learned an algorithm in school, and that algorithm is still true. That algorithm still works, and that's totally great. But I want to think about, how does that algorithm relate to what we're doing here? So here's my 236. And we subtract 129. And a lot of us learned this idea where we kind of have this rule. Maybe some of us are even teaching this in school. And again, it's still valid. I'm not saying it's not valid. What I am saying is a lot of students don't understand what's happening and why we're asking us to rename or regroup or cross things out. So here I want to look at this, and I had 6 minus 9. And I want to go back to what we had. We had 236. We had 236. And originally I said we don't have enough here to take 9 away. So when I'm thinking about this, my goal in showing this is to show the idea that when we're crossing out or borrowing, as we used to say, kind of borrowing from the 3 and making it a 2 and then making this a 16, a lot of times we go so fast that we don't make sure students understand exactly what's happening. Quite literally, when I'm taking this, I'm renaming this. So it's no longer 3 10s, it's now 2 10s. I'm not losing these 10. These 10 are still here. I just replaced those 10s over here with 1s. So now I've got 16 1s, and I only have 2 10s. I still have 2 100s. I didn't touch that at all. So then we went through here and we said, okay, 16 minus 9, quite literally remove 9. Removing those 9, we're coming into here. And we're saying, okay, let's remove those 9. There we go. I remove the 9, looking at this. And then I quite literally removed, so 16 minus 9 is going to be 7. We look at this idea, so here's my 7. And then I remove my 2 10s, so that's 0. And then I remove 100, so that's 100. So really what we're seeing is Why is 236 minus 129 107? That's what the regrouping or decomposing means. It's not just a rule. Yes, the rule does work, but we need to make sure students understand this. And it's extremely important we spend time with this. And if we see students making mistakes and crossing things out and doing all sorts of random things, I would highly recommend pulling out those base 10 blocks. Yes, it does take a little bit longer, but yes, it absolutely helps them make more sense of what they're doing. And yes, we're not going to be able to use base 10 blocks for our entire lives, but let's build that conceptual understanding first. Let's build that thinking first. So now I do want to dive into a common mistake that sometimes teachers use when they're teaching this, and I'll show you why it can be a little bit confusing for students when we're getting into here. So let me get rid of these here. And I'm going to go back to 236. I don't know why I like 236 so much today, but we're going with 236. So 235, 236. I'm going back over here, and what I want to do is I want to see a very common mistake teachers make is again, they know that, hey, when I'm adding, I simply go here and I say, okay, 236 plus 40 is 276, or 236 plus 100 is 336, and we're really good at that. But the challenge is with, and that's, by the way, that's great. We love that. So the challenge, what I do see sometimes, is when teachers are trying to use that same strategy to show that 236 minus 124. And here's the thing that I see a lot of teachers do, and they don't really know they're making a mistake. So I'm going to kind of show us here as we're doing this. If I say 236 minus 124, a lot of teachers will come in here and say, okay, let's get that 124. So here's 236. Now show me 100. And show me 20, and show me 4, and now we'll subtract this way. And the piece that I want to challenge you is that's going to confuse a lot of students. Because what I just did there is I added more tiles, I added more base 10 blocks to the paper. That's adding. That's not subtracting. I actually added more. So really what I see here is actually a little more confusing. I know the teachers are trying to set students up to say, okay, we're subtracting 6 minus 4, subtracting 3 minus 2. I totally get that idea, but quite literally, I just added more to the paper. I added more pieces here, and that's the opposite of the conceptual idea of subtracting. So instead of doing this, instead of adding more, instead of adding 124 to subtract 124, I'm going to really challenge you to say, just start with the 236 and have them pull the 124. Have them pull it into their hand or under a paper plate so we can see it. I still want to see that 124. I don't want to just drop it into a bucket with all the other tiles because I want to see how it still exists. But I'm literally taking 100, and then I'm literally taking 20, and then I'm literally taking 4, so I can see that I have removed the 124 from the 236, and I can see that I have 100 and 110 and 2 ones, so I can see that this ends up being 112 by removing, not by adding. And that'll help students to understand the idea and the difference between adding and subtracting with that conceptual idea. Yes, we will get to the algorithm. Yes, we'll get to those place value ways of looking at that, but this is a great place to start. And again, if you have students that are struggling with some of these strategies, and if you have students that are struggling with that standard algorithm that we've been looking at, if you have students that are looking in here saying, I'm not sure what to do, I'm crossing things out, I'm not sure what the things I'm crossing out, bring out those base 10 blocks and let them play a little bit. Let them understand what's happening, and always connect, hey, what did you just do with the blocks, and how does that connect to the paper? Or how does that connect to a place value chart, which I didn't get to in this video, but we'll get to that in another video. So hopefully you're understanding how I can use these base 10 blocks to help students understand. Again, we were talking about whole numbers, can absolutely use these for decimals, can use these for larger numbers too, but it's that real conceptual understanding of adding and subtracting and understanding what those different operations mean. If this conversation and this discussion of the visuals and how to use base 10 blocks and how to connect that to different ideas and strategies, if that helped you move a little bit on that continuum of understanding, feel free to share that in the comments, or feel free to share with me how else do you help students understand how to add and subtract with base 10 blocks or with other tools.